We welcome you all again for another lecture video. Myself, Sahai Shira, working with Shriram Engineering College. Today, my topic is all about electrical seismic ground penetrating radar GPR and subsurface logging. We actually been seeing a series of geoprospecting and geoprocessing. So last class we have been seeing geoprospecting. What is the difference between geoprospecting and geoprocessing? And what is geoprocessing? And in geoprocessing, another topic we will see remote sensing. Now we are going into the somewhat far about how does the raw data are being taken. That is using the electrical seismic radiations and electrical transmitting and geo ground penetrating radar and subsurface logging. Generally, we all will be having a yearly once checkup or 6 months one checkup, or in case we have even a woman is pregnant, she will be attending every 30 days once. She'll be checking about her health and also her child's health, fetus, right? That's how this electrical resistivity. You should imagine Earth is like a patient, something like that. And using the electricity, we'll be checking what is inside the earth. Like we will be passing the electricity and we will do some health checkup. If it is everything is okay to do things, what is inside, what is beneath the subsurface. Like we have to go into subsurface logging. So how does this electrical resistivity work? Is by sending electrical signal underneath and studying how the earth will respond. So it helps to find the valuable resources like groundwater, minerals, and sometimes archaeological treasures. In some movies or in cartoons, they'll be using a detectors to find any metals or if there is any golds or any kind of minerals, valuable minerals, where they'll be using an electrical a device. It gives a beep sound in it. You all remember, I guess. That's how this electrical resistivity is. It's a X-ray vision of the Earth. So this is the picture of electrical resistivity. We have two electrodes here to send the current, and another one is to receive the current. So these two electrodes are namely current and potential electrodes. The current electrode is for, see, we are sending a current through and we are sending inside beneath the surface, and we have a receiver, and that is a potential electrode. So current electrode will be sending the signals deep into the earth, where the potential electrodes are for receiving. So the potential electrodes are placed further. So this is a bit far away now. It is placed far away, and it is it will be listened carefully how the electrical current travels through the surface, like subsurface of the ground. They will measure the voltage of how does it flows easily into the deep into the earth's surface. So if I pass a current, there should be, if any semiconductor is present, then how far it will be passing? It will pass and it will come, it will reach in the same voltage. But in case if I have non-conductors wood or something like that, then the voltage will be coming in different way. The current flow will be different, it will be affected. So in simpler way, I can split it. When a water flows into a smooth surface, then the water will be flowing smoothly. If it is a rough surface now, then it will be more difficult. Comparatively, smooth surface and rough surface, it will be comparatively, there will be some difficulty. That's how the electrical current also passes. It does not always travel in a straight line. The electrical properties of rocks and soil are even different. It will affect the current flows. In such cases, voltage is the pressure of electricity. So by measuring the voltage difference, it can be concluded that there is some resistance inside the subsurface, and this is called electrical resistivity. So starting from a solid rock to loose soil, each has a different fingerprint that is called the resistivity. No, as such way the water flows into the smooth surface. No, that's how. The solid rocks has different kind of receiving voltage. The loose soil have different kind of receiving voltage. So, like copper or the great conductors of electricity have a low resistivity. It will allow the current to pass through them easily. On the other hand, like rubber have a high resist. It has high resistivity, but it does not allow the electrical current to pass through it. For a solid bedrock, have a high resistivity, and water saturated sand has low resistivity. So if it has a high resistivity, then does not allow the electrical current. It has low resistivity, it will allow the current to pass through it. So it gives a clearer pictures of how the subsurface material will be reacting to the electrical resistivity. It is used by the geophysicists. The arrays or arrangements of the electrode, that is, we have seen the two electrodes, right? One is current and another is potential. It is arranged in such a way that it is a different formation of deductive teams. Each ray has its own strength, like some are used for exploring the deep groundwater mineral deposits. In case I have a what to say, I have a Sipcot like water treatment plant beside my home or beside my site. In case my groundwater is being affected by that wastewater treatment plant, I can deduct by deep groundwater mineral deposits or by lateral mapping variation, that is identifying and partial mapping of horizontal structural, how far the soil and the rock are layered below and the material changes within the specific area. If does have any fault or fold in it, how does it has a specific layer, or it is used to analyze the crystal structure. If you have any minerals, quartz or diamonds or something, any valuable minerals, you can identify through that, or signal strength or a stratigraphic changes also we'll be able to see using the electrical resistance. So these rays can be interpreted into a data and can be further divided as maps of subsurface or a 3D map model also it can be created. So electrical resistivity is used to find groundwater from aquifer in scarred regions. Mineral exploration also can be done using electrical resistivity like gold or copper. In civil engineering, the electrical resistivity is used to find the stability of ground before building a dam or tunnel or bridge. In case I want to build this tunnel, if I have a strata horizontal or a fault or a fold, in future, due to the massive structure, it does not be affected or collapsed by the earthquake. So the environmentalist also can be used for the movement of contaminants underground like pollution or fumes. Previously, we have been seeing about the electrical transistivity, where what is the working principle? We have kept two electrodes on the surface of the earth to identify to be pass the electrical current, and one will be the current and other will be the potential to receive the refraction of the earth surface. Mean like what is under the subsurface, this will be reflecting the voltage again back to the earth surface. So now we are going to see about the seismic method. So the core concept of seismic method is to provide a detailed information about subsurface layering and mechanical properties by measuring how far the waves can travel through different rock bodies. Before we used for all kind of like say water for rocks for soil we have been using electrical resistivity. Now the seismic is only used for different types of rock bodies. So what are the equipments? Previously, we saw two electrode we should be keeping in electrical resistivity, but here we will be keeping a receiver, a recorder, and a source. So the receiver will be the geophones, and the recorder will be the seismograph, and the source will be the seismic Humper trunk. That will generate the waves. So before going into the working principle of seismic method, first we have to know what type of seismic wave we'll be getting from the earth. There are two types of waves. First is body waves and other is a surface wave. You know what is body wave? That is propagate through the internal volume of the earth. That is primary wave. And secondary wave, it is related to earthquake, right? Primary waves, the wave that will travel faster, that will reach a seismograph first. Their velocity depends on the rock elasticity properties, primary wave. Secondary waves will travel slower, but it will be traveling in a perpendicular manner uh, on the material. Next is the surface waves, that is love waves, railing waves, seismic method subdivisions. This will travel slower than the body waves. Usually, the love waves, that is L wave, will be traveling in perpendicular to the wave direction and parallel to the surface. Okay, it will the move the love waves particle will move in a parallel way to surface, but in a perpendicular to the wave direction. Next is Rayleigh waves will feature elliptical particle motion in a vertical plane. This is how the seismic waves are differentiated. Now the seismic waves methods will are being differentiated into two methods, that is reflection method and refraction method. So the reflection method is primarily used in oil and gas exploration. It measures energy reflecting above subsurface boundaries to create high resolution images on rock layers. Then this refraction method will determine a P wave velocity structure, that is body wave, primary wave, right? It is often used to map low velocity deposit like gold or gravel or in geo-environmental work to study tailing or acid mine drainage. So this refraction method will be used in civil engineering to know about the minerals, to know about the stones, to know about the rocks, or to know about the different valuable material which is present beneath the earth surface. Okay. So the what are the applications in seismic method is hydrocarbon exploration to provide a high resolution map on. So in hydrocarbon exploration, we know that remote sensing or this seismic method, to get a remotely data, we can use an infrared images to get the high resolution map of acoustic impedance to locate a potential petroleum reservoirs. So beneath the surface. Mineral exploration is to help identify massive sulfide bodies which typically have higher seismic velocity than surrounding rocks. So, as I said before, minerals have different types of intrinsic properties. It can reflect, it will give into a different types of wavelength it will emit. It will have different types of wavelength so that it will the energy will be absorbed. The reflection using the reflection will get a voltage or a wavelength. So, using that we will identifying the mineral exploration. Next is geological structure, used to predict the depth and thickness of various geological strata. Like wise we can know about the fault or the folds in case you are building a tunnel or a dam or a bridge to know the subsurface stability to withstand the massive structure. So the goal of this seismic method is to suppress noise and enhance signal to allow for accurate interpretation and modeling of Earth surface. So comparing with the seismic method with electrical resistivity, we can suppress noise and enhance the signal so that we can find especially like sulfate bodies to find gold or gravel. In particularly, we want to find some valuable things. We can enhance the signal to allow and we can get an accurate interpretation and modeling of Earth's surface. So this is how seismic method is being used. This is the pictograph of seismic method. It has a seismic source, geophones or the receiver, and we send signal. We send direct signal or a critical signal, and the critical signal will be refracted, and the refracted wave will be going to the surface. It will be received through the geophones. So the last topic is the ground penetrating radar. We have seen the active remote sensing in that we have used the word GPR. So we have used the in active remote sensing that we send radar signal or radio signal and it will bounce back from the Earth's surface. That's how we get data likewise we have seen before earlier. So now, how does it works? What is the word bounce back really means is it will cause electron to oscillate. You all know electron will be revolving and that will oscillate and it will re-emit the energy as a new wave. Why does it re-emit the energy as a new wave? Because any charged particles, that is, it is charged through electromagnetic field that will accelerates must emit its own electromagnetic radiation. While it is oscillating, it should accelerate and it will emit its own electromagnetic radiation. That's how it bounces back. Okay. So now into the topic. GPR works by sending the pulse of electromagnetic field into the ground and it will record the reflection that bounce back. As I said, it should do it and in the opposite direction from various subsurface material with a different dielectric properties. That is the phenomenon of reflection. If I emit the light, it should absorb and it should reflect, right? That is the phenomena of reflection, like radio waves or X-rays or light, sunlight, infrared light, or thermal red infrared light, anything. It will strike the surface. Generally, it can be a conductor or a boundary or a reverse direction and travel backwards to the source or the another location. That's how the picture be taken out. So, what does the system consist of? The system has a transmitter antenna that emits the radar signal and a receiver antenna that captures the radiator reflected signals. So, there will be two things to emit the radar signal and to receive. We have two antennas there. Captures the reflected signals. This is the process. By analyzing the time delay, so in between, no, in this meanwhile sending the signal, emitting the radio signal and reflecting the signal, no, in the meanwhile if there is any time delay and the amplitude of the reflected signals, GPR can provide valuable information about the subsurface without the need for excavation. So this is how it works. So principle of radar is the radar signal emission. The GPR system emits short pulse, like pulse. How does the pulse of our body it works? In a short time, it has this much amount of pulse it should work, right? So it will emit some short pulse of EMF, that is electromagnetic waves, typically in a microwave frequency, ranges into ground using a transmitter antenna that will be the emitter. And step two will be propagation through ground. That emitted radar waves travel through the ground, and as they encounter different materials with varying dielectric properties. As we said before, intrinsonic property like this, if they have a varying dielectric properties like soil, rocks, voids, buried structures, some of the waves are reflected back towards the surface. Step three will be the signal reception. The another antenna which receives the reflected signal that and its step four will be the analyzation. Analyze and interpret the recorded of unprocessed data into a processed and they will analyze to create a subsurface profile, often displayed as a cross-sectional image. Radiogram changes in diametric properties of the subsurface material will cause variation in reflected signal that are used to identify the buried objects or structure. In case of archaeologists, if there is any kind of um, like systems has been buried underground. It has been like 50 years. There is a building inside the ground. We can, using these signals, we can get the buried objects also, or even the structure can be identified using GPR. As we saw in the steps of GPR, so first application is finding out the subsurface historical sites for identifying any buried structures or ancient remains which is buried, which is not known to human eye. So we can identify using GPR. And second is to detect and mapping underground utilities like underground pipes, cables to prevent damage during excavation and construction. If it is layout for sewer or sewage, and in such cases, without digging out, we can identify how far it is being maintained inside. to also to identify the soil and groundwater contamination, to locate the buried drum tanks or hazardous materials. Sometimes if you have any bomb left over in a war and you need to find out, you can find some hazardous materials also using this GPR. To find the geological formations like bedrock fault or folds, which was actually formed during an earthquake or any accessing or a payment conditions which was being used by ancestral pathways for their war preventing themselves being hurt. So all this can be found using using by GPR. So it is a non-destructive subsurface investigation used for subsurface exploration without excavation, because for a large scale of excavation we need a large money to excavate, and then we have to do the processing, and we does not know how far it has been present. If it is not, if you are going to dig it out or you're going to excavate a large scale of place, no, then we need large amount of money. We does not know which height it is being present. So in such cases, you can use GPR as a source for digging out and excavating without spending a money on that. So as I said before, this is the pictograph of GPR. We have a control unit. It has a receiver and transmitter antenna. It will transmit the signal like short pulses, and then that will be reflected or reflected energy will be received by the through the receiver antenna, and then that will be the data will be stored, and some data will be like displayed. So this is how it will work. Thank you.